Colorful, aren't they?
What's in these test tubes?
Well, the solution in these test tubes is the same solution as in this flask. And it contains 0.20 mole per liter copper 2 sulfate solution and saturated potassium bromide solution. Now, they've reacted, and I've got these three solutions in which I'm going to now look at equilibrium and chemical reactions, and you're going to help me.
Well, how are we going to study chemical reactions? There's nothing happening here.
Well, there is. I'd like you to take these three test tubes and put them in each of those water baths.
Okay.
I've got one at room temperature, and that's it. And the other two, one in hot water and one in cold water. Now, Amy, can you take a temperature reading just to verify
Okay.
that I have these right temperature ranges?
The hot water bath has a temperature of 60 degrees Celsius.
All right.
The cool water bath has a temperature of 4 degrees Celsius. And the one at room temperature is at 25 degrees Celsius.
Good.
But what's happening in these test tubes?
Well, let's look at the chemical reaction. Copper 2 sulfate, which is blue species, reacts with potassium bromide, which is colorless, to produce a green copper bromide complex and colorless potassium sulfate. Now, when I add heat energy to the system, the equilibrium shifts to favor products. Therefore, we have a predominance of the green copper bromide complex. Now, when I take energy away from the system, that is, cool it off, the equilibrium shifts to favor reactants. Therefore, I would have a predominance of the blue copper 2 sulfate ions. All right. Now, from this information on this reaction at equilibrium, can you now make some observations over here and some conclusions?
Okay, well, I can tell by looking at these that they're different colors, so they each must contain different amount of the colored ions. The one in the cool water bath is a bit more blue, so it must have more copper 2 sulfate in it than the green copper bromide complex. And the one in the warm water bath is considerably more green, so it must have more green bromide copper complex in it.
Right, the copper bromide.
Than the blue copper 2 sulfate in it.
Correct.
And the one that was at room temperature appears to be bluish green, so it must have approximately equal amounts.
Good. All right. Now, what can you summarize about all of this as far as equilibrium and chemical reactions?
Well, chemical reactions don't always go to completion.
Correct.
Sometimes reactants are favored more than products.
That's a point up here.
Other times, products are favored more than reactants.
The second point we make.
And sometimes still, there's about equal amounts of reactants and products.
Good. And that's the third point we can make. Okay, I think you've got it. Now let's look at this equilibrium system again. Regardless of the quantities of the reactants or products, the rate of the forward change is equal to the rate of the reverse change. Important point to remember.